Here we have the project vehicle motor over speed detection system. So this project, I'm explaining about the components. We have used Arduino Uno 16 by 2 LCD display with the I squared C converter, I squared C module, and we have a potentiometer to increase and decrease the speed of this DC motor. We have used a DC motor just as a reference for speed motor, and we also have the IR speed sensor here, which is connected through a created wheel where we have slots holes here. So we can see that IR sensor is in between this wheel where there are slots. Okay, and we have the on off switch for DC motor, and this is powered with 3.7 volts lithium ion battery, but 3.7 volts is not sufficient for the system, so we are using the voltage boost converter here, which boosts the voltage from 3.7 volts to 5 volts, which is required for our Arduino. So this is the system. So let me run this first. So before that, I will restart this project, reset this. Okay, so now I reset the project. Now we can see that its speed detector is showing on the display, and then right now motor is not running, and we are not calculating any speed. So how this works? So let me explain the working process. So Arduino, uh, IR sensor is input to the Arduino, and we have the LCD display which is output to the Arduino. This motor is completely separately powered from the Arduino system because motor required a lot of power. So motor is separately powered, it is not connected to the Arduino. Potentiometer is in series with the DC motor, so it will send less current or more current. Based on the current value, the speed of the motor changes. So if we set the potentiometer to the low resistance, then speed of the motor will increase. If we set the resistance of this potentiometer is high, then speed of the motor decreases. This works just like the volume button in our old TVs and radios and stereo systems. Okay, the potentiometer is that one. And IR speed sensor works like a speed detector. So when the wheel is rotating, there is receiver and transmitter inside this. So the transmitter will send the signal. If there is an obstacle, the receiver will not block if it is passing through these lines. And when the wheel rotates, you can see that I'll slightly move this. So this another LED turning on when a light is passing on that. Okay, so that's how this works. Fine, and let's turn on this first. So I turned on, but the motor is right now in 0 position, so I'm slightly increasing the speed. So we can see that, okay, motor is overspeeding, and we do have the SMS sending system which we have not yet installed yet. Okay, now the motor speed is 45 rpm, the vehicle speed is 73 kilometers per hour. You know that like engine speed is not always equal to the vehicle speed. So now here motor 42 rpm actually shows how the engine is speeding up, but speed is always less. Now we are converting this motor speed into the actual speed by using some calculations in the code. So let me slightly increase the speed. Now the speed is 83 kilometers, 101 kilometers per hour. I have set this speed to 120 kilometers per hour, which is overspeeding actually. Okay, now let me show you how this is blinking. So as it is rotating, we can see that the LED is blinking very fast. In video it is slow, but in real time it will be very faster. And there are 20 slots in this, so we are dividing every rotation into 20 divided by 20. That's how we get the count, and multiplying with the 60, that is 1 second. uh, uh, and yeah, so every rotation multiplied divided by 20 and multiplied with 60, that's how we get the hour speed. Okay, that is kilometers per hour we are converting it to. And yeah, this is how the system is working. So if I increase slightly the speed, over speed, now the speed is more than 120, so it is sending the SMS. So we need to connect the SMS module here more. And yeah, that's how the system works. Right, so the methodology first we learned about the Arduino Uno working, how it works, the pin configuration, the analog pins, digital pins, etc. And we also learned about LCD with I2C I2C, which works with I2C protocol, and we also learned about the DC motor, how it works, positive, negative, and we learned about the potentiometer, and we tested the motor first with Arduino, and then we tested this with the speed with LCD, and then finally we learned about the IR sensor. And after learning about IR sensor, we given like how many calculations we need to take, how many rotations, count, etc. we need to take, and then we updated that to the Arduino. By combining all these learnings, like individual learnings like DC motor, IR sensor, LCD display, potentiometer, all combinedly we made the final project by converting the code, all different type of codes, into the single code. So this is the methodology of the project. Now the outcome is we can actually regulate the speed of any vehicle or monitor. The future scope is that this can be directly connected to the IoT, so that the persons or the control center can directly view the real-time speed, not only over speeding but any speed like 20 kilometers, 30 kilometers, etc. So the control center can detect the speed and monitor the speed. They can see, and we can also update in future scope about the GPS, like where the vehicle is located and how it is moving, just like in our Google Maps. And we can give future scopes, like we can restrict the motor speed also by using the gearing system or speed controlling system, etc. So that's all about the project, and for more projects, more knowledge, we'll see through. Okay, thank you.